Okay, so we're going to look at, we need to show that sometimes a series is decreasing over the interval, in this case from 1 to infinity, in order to use some separate tests, some different tests. We're actually supposed to use that for the integral test. In order to use the integral test, you're supposed to show the series was decreasing, but I didn't feel like doing it. But we need it for alternating series, so I thought I would revisit it. In order to show that something is decreasing, in general, you're supposed to show that some term is going to be less than some term before it. So this should make sense, right? So in general, the 11th term is going to be less than the 10th term. Well, then that's probably decreasing. So hopefully you're thinking back to Calc 1 when you had to show something was decreasing. I'm going to rewrite this as a function of x. So this would be 4x cubed. And if I wanted to show that this thing was decreasing, I would just use the first derivative, right? So we would just do f prime of x. I'm going to rewrite this as 2x to the 3/4. And to take the derivative of this thing here, I'm going to rewrite it as 2x to the negative 3/4. So take the derivative, finally. We would get negative 3/2 x to the negative 7/4. So the only time this thing is zero, really never zero, but it is undefined. So because really this is the same as negative 3 over 2x to the 7/4, right? This thing is never equal to 0. However, it is undefined at x equals 0, right? So f prime of 0 does not exist, and that qualifies it as being a critical number. So if I plug in, so that means, let's just draw a little number line here. Here's 0. Notice that my values I'm talking about are from 1 to infinity. I'm really looking at really positive numbers, right? So the f prime of 1, I just need to show that some number to the right of 0 is negative, and therefore I can show that the series is decreasing. Well, if I plug in 1 here, I really just get negative 3/2, which is less than 0. So therefore, my series is decreasing on 1 to infinity, right? So series is decreasing on 1 to infinity. So therefore, we can use this in some future problems. This is one way to show a series is decreasing. To me, this is a pretty easy series to work with. I'm going to show you a simpler way in a minute, but if you just want to go back to old school Calc 1 to show something is decreasing, obviously you just take the derivative like I did here. Notice I took all the n's, turned them into x's. I took the derivative, I found the critical value, which in this case was 0. I showed it was negative on the interval from 0 to infinity, and therefore my series is decreasing on this interval. So let's try a different way in a second.